To help the people who are trying to draw the flat Earth map, you will need a sundial compass or a sundial and a compass, an object that stands perpendicular to the ground. You should already know the height of the object, or it should be easy to measure. Something to see the standard time like a smartphone, a camera to film what you are doing, and a paper and pencil to write everything down. You should put the sundial and the compass and the object in one line close to each other. If you're using a sundial and a compass separately, use the compass to orientate the sundial to magnetic north. Measure both the length of the shadow and the height of the object, and if you can do the math, great. If the math looks too complicated, don't worry. The measurements of the shadow and the object will be enough for them. They will do the rest. Use a camera to record the standard time and the sundial time. Also record the directions of the sun and shadow while you measure the shadow of the object. To do this, use your pencil or pen or other small stick and place it near the compass or in the center of the compass. Always keep the compass pointing north. When you're done, write your information in Excel and send it to the researcher. The Excel sheet is in the description. Here's an example. It doesn't have to be done at your house. You can go anywhere and use the location of the place you recorded your information. How to use the sundial compass to collect information for tracking the sun. I purchased my sundial compass from Amazon, and it was very inexpensive, as you can see, less than $12, and it's actually pretty nice. It's brass and it looks pretty cool. When I received my compass, it came in a box like this, and it was well wrapped in bubble wrap inside. I've already opened it, so there's no bubble wrap now. But it did come wrapped in bubble wrap. And it also comes with this little arm that is attached to the needle inside the compass. And what you have to do before you can use it is get a little flathead screwdriver and loosen the screw on the side until the needle spins free. Now be careful when you do this not to unscrew the screw all the way, because I made that mistake, and there's a little piece that inside that doesn't come out, and you need it to be stuck to the inside of your compass. So just unscrew it enough for the needle to spin free. It also comes with these 3 adjustable legs, and you're going to need a small level to make sure that your compass sits level on the ground. So that's it, so let's go set it up. You're going to need to find your degree of latitude. Go to Google Maps, right-click on your location, and select what's here. At the bottom of the screen, some numbers will pop up, and the first number on the left is your degree of latitude. To set up your sundial compass, take it outside and set it down in a sunny spot. The first thing you do is lift up the arm on the compass. The numbers on that arm represent the degree of latitude. Stand up the gnomon as straight as you can get it. Then lift the face of the compass to match the correct degree of latitude. Use your level to level the compass and adjust the legs as necessary. Make sure your compass is facing due north. Once you have it placed, let the needle settle so that you make sure that you're facing north. Here you see the shadow that the gnomon casts on the face of the sundial, telling you the solar time. Measure the height of your object and measure the length of the shadow. Here I use my pencil to find the direction of the shadow and the sun. Don't forget to record the standard time of when you took all your measurements. To measure the angle of elevation, you need an object that stands perpendicular to the ground. A little Lego tower works well, and you can build it to be an even numbered height. You need to have a right angle formed by the object and the ground. Measure the height of your object and the length of the shadow it casts on the ground at the time of your reading. Convert the height to inches if it is taller than 1 foot. This makes it easier to compute, as you will see. We will refer to the angle of elevation as theta. In trigonometry, the tangent of an angle is equal to the length of the side opposite the angle divided by the length of the shadow. So the height of our object is 4 inches and the length of the shadow is 5 inches. When you divide 4 by 5, you get 0.8. On a scientific calculator, under the second function, there is either an A tan button or a tan -1 button. They are the same thing. Make sure your calculator is in degrees mode. Type in 0.8 and then hit the arctan or tan -1 button, and the number you get is the sun's degree of elevation. Important information to record. The date and standard time you recorded your information. The time on the sundial. The height of your object and the length of the shadow of the object. The latitude and longitude of your location. The direction of the shadow and the sun. This can be done at any time. Recording data at different times is extremely useful to people researching the sun's behavior. If you are recording data for an event that calls for data taken at solar noon, please use your sundial compass to identify when solar noon occurs in your area 1 to 2 days in advance. Standard time for noon and solar noon can differ by 1 or more hours. Thanks for watching and happy tracking.